Hello, my name is Brittany Jackson, and this presentation is going to be about the existence, reactivity, and applications of the element arsenic. First of all, the objectives that we're going to cover are understanding the need for arsenic-based education as it relates to problems we have in society. We're going to identify some research-based learning strategies that are effective to increase student learning and engagement and deeper levels of thinking and critical thinking related to arsenic. Present information related to the existence, reactivity, and applications of arsenic appropriately. This focus is going to be on undergraduate level students. Relate environmental issues of arsenic to problem-based learning strategies for the purpose of student collaboration and feedback from instructors, and utilize current research for expansion on this topic. So why do we need to talk about arsenic? Well, arsenic is a very well-known carcinogen, and it can cause many health problems in humans and animals in all ranges of the ecosystem, and it can lead to types of cancer, including skin, bladder, or liver, among others. It does have cytotoxic and genotoxic nature, making it dangerous to cells and genetic information in the cell. Chronic exposure can lead to arsenicosis, which consists of skin lesions, disease, and cancers. Other than the cancer, arsenic can lead to multisystemic disease like cardiovascular problems, diabetes, etc. This is the hazard identification for arsenic. It is a brittle, crystalline silvery black metal. It causes irritation, damage to organs and nervous and cardiovascular systems, as well as a cancer agent, and is normally found as a powder, and it is flammable. So arsenic has some common and important uses. It's mostly been used as a doping agent in solid state devices. Compounds like gallium arsenide are used for lasers that can convert electricity into forms of light. Arsenic compounds are often used for insecticide purposes, along with in poisons. So some other forms of organic arsenic, keep in mind that you can find inorganic and organic forms of arsenic in the environment, but organically it's used as feed for animals and for disease treatment of animals. So that would be a benefit of arsenic, but if you look at it environmentally, we're still, by using it for the animals in agriculture, still increasing exposure in the environment. So other industrial uses would include alloy manufacturing with lead and copper. Arsenic is typically not found as a free element. It's usually found partnered with other compounds and material for its uses. So here are some applicable teaching methods if you were going to teach about arsenic to the undergraduate level. So research has shown that students at the college level in higher ed, especially in the STEM classrooms, have an increased learning possibility when they are encouraged to analyze and challenge questions that are presented by their instructor via small group collaborative setting. So the way this works is that these instructors can facilitate a classroom discussion and encourage this discourse through using what are called TDMs. And so these are teacher discourse moves. The conversation methods can be started by an instructor to help the students understand the content better. So these are strategic questions aimed at increasing student understanding that are going to foster learning and engagement and deeper levels of understanding about the science concept itself. So ultimately, you're putting these students in collaborative learning groups. You're starting strategically planned discussions, and then you're having the students to have this discourse amongst themselves and to challenge the questions and talk with each other. So one example of this is the Initiate Response Feedback, or IRF, which introduces opportunities for engagement and collaboration discussions. This is a very effective method that encourages critical thinking and thinking outside of just simple answers. So you're going to have them support their answers with evidence or justify them. So that's going to be a higher order thinking skill. So this is my approach recommendation based on this problem-based learning collaborative approach. So I recommend developing a collaboration assignment for your students related to these environmental arsenic issues. This could be problem-based learning approach, and students will work to develop solutions to these arsenic-based problems. But they really need to use current peer-reviewed research and best practices to support and justify their recommendations to the problem solving. So they don't need to be just coming up with random things off the top of their head. They need to have something to justify, okay, here's my solution to there being too much arsenic in the environment. Here's a way we could mitigate that. And here's my research that supports that that is something that we could do. So here is an example of an IRF type conversation. So it starts with the initiation. The instructor will ask a question or initiate a question to the collaborative group. So in this case, they may say, what are some current environmental issues related to arsenic and how do they affect us? Next comes the response, the received answer from the student. So the student is going to respond to their question. Therefore, in this case, the student would research and present their responses. So now comes the feedback. So the instructor will prompt the student for a follow-up dialogue. The teacher may ask the student to explore further on the ways these issues can be mitigated and what options do we have available, or do some need to be invented or researched further. So that's an example of how to engage in the IRF. But of course, you can interchange these questions and things. All right, so now to the meat of what I would cover if I was trying to hit these topics on the reactivity, existence, and application of arsenic. So arsenic has a natural occurrence. It's an element, as I said before, typically not found as a free element. It's usually a constituent of sulfidic ores as metal arsenides like nickel diarsenide. So it's usually found among compounds. Other types of arsenates that occur naturally with cobalt, lead, magnesium, natural sulfides of arsenic, among other things. It can be found in varying forms within rocks, water, organisms, and soil. So it's found in many ranges of our ecosystem. Typically, the concentrations you may find will range from parts per billion to parts per million. And here you can see a picture of gallium arsenide on the right. Properties of arsenic. So its valence oxidation state, it has quite a range here. It can go 3-, 0, 3+, or 5+. Some of its allotropes are yellow arsenic, which has a specific gravity of 1.97. You have gray metallic arsenic, which is a more stable and common form. Have its melting point, boiling point, its structural characteristics. It oxidizes quickly after being heated, and its self and related compounds are poisonous, and the known isotopes include 30 different ones. Here's some reaction information about arsenic. It related to its mobility and redox potential, its adsorption and desorption in the environment, information related to its pH. So this is information on how we can actually detect the arsenic in the environment. We have plasma source spectrometry. We have the HPLC methods. We have the ICP-MS. And here on the right is a picture graph of the data collected from using the HPLC ICP-MS chromatogram among arsenic species in the environment to get their levels. So the HPLC, from what I found, that form of separation of arsenic species is already found quite frequently in the literature. All right. Current environmental issues with arsenic. It's typically the problem comes in with these copper ores used in mining and metallurgical operations. In certain processes that happens, oxidation will occur and there will be a release of gases like sulfur dioxide. This leads to formation of acid wastewater, and the high arsenic concentration along with this is a cause for ecological concern. We have sulfide precipitation, which is a proposed way to deal with this type of wastewater, since the arsenic in it can be precipitated as the arsenic sulfide sludge, or ASS. And I have put a picture of how bioleaching of these arsenic bearing copper ores occurs in the environment here to the right for you. And there are varying methods to safely dispose of this sludge that's created. All right, so some research, and resources for expansion. So this research here by, Kolya et al. Is going to address methods for detection of arsenic using different metal-based nanoparticles. Colorimetric detection is a way of doing this, and it talks about that. And so also, as mentioned down here by Burton et al., this research looks at the role of microorganisms in remediating arsenic pollution through biotechnology applications, which is really interesting. So it actually shows how there's actually a good bit in the literature about that, using microorganisms to break down and remediate the arsenic in the environment. And here on the right, you can see those gold nanoparticles, or AUMPs, which are recommended. And then this is an example of an enzyme within the types of bacteria that are used, that actually these bacteria can breathe the arsenic, so they are able to utilize it and uptake it. And here are the references. And that is all. Thank you so much.